Hi, everybody. Welcome back. Let's talk about light, what it is, and how we measure it. Light is a form of energy, and it's part of the electromagnetic spectrum, all right, which ranges from radio waves, gamma rays, you've got some UV and infrared on there, and a very small sliver of that electromagnetic spectrum is visible light. Visible light is that portion that of the spectrum that our eyes are designed to receive, and it makes up less than 1% of the spectrum, interestingly enough. How do we measure light? It turns out that we need to measure it in many different ways. So we're going to go through them in this video. Go ahead and open up your book to page 368 here, and in table 12.2, you see a list of the different ways that we measure light and the units in which we measure them. So along the left-hand side of this table are the different qualities of light. Light supply, also called luminous flux, luminous intensity, illuminance, and luminance. These are very hard to tell the difference, in my opinion, just by the name. So we'll go through each one of them. The unit of measurement, lumens, candle power, etc. We'll talk about each one of those also. The first one in your table is called supply of light. And in other textbooks and in other realms, this is also called luminous flux. So the supply of light is a rate at which a light source emits light energy, and it's measured in lumens. And here's a good analogy. If we're thinking about a flashlight is supplying light, well, a water hose here is supplying water. And we can draw an analogy between the gallons per minute that is pouring out of that hose and the lumens that are, quote, pouring out of the light fixture. All right, so you can see that lumens are a flow rate measurement. The next vocabulary word I'd like you to learn is efficacy. This one might be a little hard to say, so go ahead in the privacy of your own home right now. Let's give it a couple of times to practice. Efficacy, efficacy, efficacy. All right. And what efficacy means, it's the ratio of the light output to the energy input. And it's measured in lumens per watt. All right, so we're measuring how much light you get out for every watt of energy you put in. Let's take a look. There's three examples in your textbook right here. We have an incandescent lamp, a fluorescent lamp, and a high pressure sodium lamp. And in this example, each one of them is being supplied with, has an input of 100 watts of energy. But you're getting different amounts of light or lumens out of the fixture. All right, so the incandescent has 1740 lumens, fluorescent 7800 lumens, and this high pressure sodium has 9500 lumens. That's the light that's coming out of this fixture when you supply it with 100 watts of energy. So in finding the efficacy, you take the lumens and divide by the watts. You get lumens per watt. All right. The efficacy of the incandescent fixture is fairly low, 17.4 lumens per watt, all the way up to this high efficacy number of 95 lumens per watt. All right, so what you're looking for in order to reduce your energy use is to select high efficacy light sources. The next way that we measure light is called luminous intensity, or also called candle power. These mean the same thing. All right, and this metric measures the intensity of light in a specific direction because light is directional. All right, so candle power is measured in candela. That's its unit of measurement. And so take a look here. We have two different light fixtures, and they are both providing the same amount of lumens, 2,000 lumens. But one of them, the spotlight, is highly focused. And in this one direction, okay, because candle power is directional, its measurement is 7,400 candela. The flood fixture, on the other hand, spreads its beam far wider, and although it's providing 2,000 2,000 lumens, they are spread over a wider distance. And so if we were just measuring in the one direction, all right, it has far less candela, 1,100. Because it's directional, candle power is often represented or illustrated by a graph rather than a single number. So the last example was a single number because we were very specifically looking at one particular direction. All right, but if you're interested in the pattern of distribution, you want to take a look at a candle power graph instead. And these are supplied by the luminaire manufacturers for each different fixture. Let's talk about illuminance next. Illuminance is the amount of light that falls on a specific surface. We're often very interested in how much light lands on a work surface. Maybe it's a desk, that's a common example, or sometimes it's a kitchen counter. All right, so whatever the task surface is, we want to know how much light is arriving there. Illuminance is measured in foot candle or in lux. And the difference is, oh, it looks like I got them swapped on your slide here. Foot candles are lumens per square foot, all right, and lux is lumens per square meters, all right, so that's the difference between these two terms. So let's take a look at this example here. We have a light fixture, unknown, somewhere above, okay, it's not in the illustration, and it's providing an even distribution of 80 lumens to this task surface. All right, now think about this. Remember our water analogy. Think about this as perhaps it's raining down, and we want to know how much of that light arrives at our task surface. All right, so we can divide the lumens per the square feet, all right, and end up with 20 foot candles, or the lumens divided by the square meters. Looks like I need a little square there, and it's 222 lux. The last two terms I want to talk about in this video are brightness and luminance. Now, these are related terms, but they don't mean exactly the same thing. All right, these are not two names for the same measurement as was in a previous slide with the candle power. All right, these are two slightly separate topics. And both of them, where I'm linking them here because they both have to do with the amount of light that ultimately reaches its end destination, which could be an observer's eye or a specific location in a room. So let's talk about luminance first. It's an objective measurement, and it's measured in candela per area. All right. Luminance depends on the initial illumination, how many foot candles are being provided, and it also depends on the surface that's reflecting the light. Right? Now, most of the time, unless you're looking directly at the sun or directly at a fixture, you're actually getting reflected light. So it's very important to know, is the surface which is reflecting this light, is it light colored or dark? Is it shiny or matte? All right, these things really make a difference, and luminance is how we tie them in to our design. And also brightness. Brightness is a similar concept. It's the amount of light that reaches the perception or the eye of a human observer. All right. Now, this is even a little bit more complicated because of the human factor. All right. So it does depend on the luminance, all right, the objective measurements, but it also depends on the human. And the adaptation of the eye, is the pupil dilated or pinned, or is it open or closed? Okay. And it also depends on contrast with adjacent objects. Is the adjacent object very bright? Is it dark? So contrast plays a large role in there. All right, everyone. In this video, we just covered what light is and how we measure it, several different metrics used to measure light. In the next video, we'll talk about um, how much light is needed in your space. Thanks.